Okay, we are on our review. We're continuing on the review. Worksheet 6 for Unit 13. This is going to be the last 2 pages of the review, pages 4 and 5. Okay. For what value or values of x does f have a discontinuity? If f is this rational function, the numerator does not matter. I don't care if it factors. It doesn't affect this at all. The discontinuities only come from the bottom, and when x is 3 and negative 3, we have a discontinuity. For what value of x does f have a discontinuity if f is this function? Once again, numerator does not matter. The discontinuities come from the denominator. The values of x are 0, negative 7, and 4. Those are the values that make the denominator 0. Number 59. Which of the following is continuous at x is equal to 1? Continuous at x is equal to 1. Limit from the left is equal to the limit from the right, which is equal to the value of the function at 1. Okay, so for this first one, got a little piecewise function. I'm going to factor the top, and I get x plus 2, x plus 1, x minus 2, x minus 1, over x minus 1. We can reduce those x minus 1s because x is not equal to 1. That's why we can reduce those. I'm left with an x minus 2, so this is the same as x minus 2. Now if I put a 1 in for the remaining x's, I get a negative 1 on top. On the bottom I have a 1. Those are not equal, therefore there's a jump, there's a discontinuity at x is equal to 1, so not 1. Okay, actually that would be a point discontinuity there, a hole. There would be a hole there. Alrighty, for this one, I'm going to put 1 in for this x. There's going to be a 6, half of 6 is 3, plus 1 is 4. Put 1 in for this x, 5 minus 1 is 4. Those are the same. What about right at 1? Right at 1, I'm still putting 1 in for this x. I'm still going to get a 4. 4 equals 4 equals 4. We want to keep h. For g, it's not piecewise. All I have to do is look down here. If I put a 1 down here, I get a 0 in the denominator, not continuous. The only continuous one is is h, which is b. Alrighty. Okay, number 60. We've had these before. What value of k makes f continuous? Okay, so I'm going to put a 4th in for the x, a 4th in for x, set them equal, solve for k. So k times a 4th cubed is 1 over 64. K times a 4th is k over 4. Set that equal to 16 times 1/4 squared, 16 over 1/4 squared, minus 2. This is a negative 1. I'm going to multiply both sides by something that will get rid of all my denominators, a 64. I'm left with k minus 16k minus 16 is equal to 64. So negative 15k is equal to, this is a negative 64. I'm adding 16 to the other side. I'm going to get a negative 48. K is equal to negative 48 over negative 15. 48 over 15 reduces 2. There's a 3 in that. 1, 6, and then 5. So that's 16 over 5. C. Okay. Number 61. Okay, let's see. G is a piecewise function. Which of the following statements is true? Be careful with that. Every once in a while they throw a is false at you. Infinite discontinuity. That means a vertical asymptote. Does G have a vertical asymptote at x equals negative 7? Negative 7? Yes, that's a vertical asymptote. That is true. So I'm going to be keeping number 1. Non-removable discontinuity. A non-removable discontinuity is a vertical asymptote or a jump. So G has a vertical asymptote or a jump at x equals -1. -1, that is not a jump or a vertical asymptote. That is false. That would be a removable discontinuity, a hole. Okay, G has a removable discontinuity. Removable discontinuity has got to be a hole at x equals -6. I go to -6. At -6, that is not a hole. That is a jump. The bottom of this graph got cut off, but either way it doesn't really matter because there's clearly a jump there. So not a removable discontinuity. The only correct answer there is number 1A. Which of the following functions has a jump discontinuity at x equals 4? At x equals 4. So that means that the limit from the left is not equal to the limit from the right, but they both exist. So if I put 4 in for this x, I'm going to get 16 minus 8 plus 3. 8 plus 3 is 11. If I put a 4 in for this x, I get half of 16, which is 8, plus 4 minus 1. 12 minus 1 is 11. Those are the same. At 4 it's the same. F is continuous at x equals 4. It does not have a jump discontinuity. Okay, put 4 in for x. I'm going to have 2 times 16, which is 32, minus 3 times 4, which is 12. That gives me 20. Put 2 in for this x. 8 plus 16 is 24. There's a jump there. There's a jump there. So jump discontinuity for g of x. For h, okay, I noticed this thing. This is a parabola everywhere except exactly when x is 4. There is no way that could be a jump discontinuity. Can't be. This is a parabola everywhere except x equals 4. So at most there could be a hole, but it will not have a jump discontinuity. So the only correct answer there is D. Okay, number 63. Hang on tight for just a second. Alrighty. Prove that f is continuous at x equals 0 if this is your function. Well, the first thing I'm going to do is I'm going to come over here and I'm going to clean this guy. I always go and clean up anything like that. Okay, I'm going to clean that up by, I'm going to just factor out an x from the top. And on the bottom, I can factor out a 2x or an x. I really only need to factor out an x because I'm going to be reducing the x's. But if you wanted to factor out a 2x, you certainly could. Now, these are going to reduce out. And so this is the same thing this is the same thing. These reduce out, by the way, because x is not 0. If this included 0, I would have to keep them. Okay? This reduces to x plus 4 over 4x plus 2. Okay? Alright. Limit as x approaches 0 from the left. To prove continuity or discontinuity, you have got to show these limits. Limit as x approaches 0 from the left, limit as x approaches 0 from the right, and then you're going to find f at 0. 3 steps every time. Left, right, and then dead on. Okay, from the left I'm using this piece. And I'm putting 0 in for the x's. If I put 0 in for the x's, I get 4 over 2, which is 2. Okay, 0 from the right. Now I'm using this piece. I'm putting 0 in for the x's, and I get 2. F of 0. F of 0. Now I'm using this piece. Put 0 in for x, I get 2. Therefore, f is continuous at x equals 0 since the limit as x approaches 0 from the left is equal to the limit as x approaches 0 from the right is equal to f of 0. This is what is required for a proof for continuity. And remember that there is one like this on the test. Okay? I forget if it's continuity or discontinuity, but one of these. And each way, you have got to show it like this to get credit for it. Okay? Alright, and then the last one here, 64. Prove that G has a discontinuity at x equals 7, if this is G. Well, I'm going to begin the same way I began the last one. I'm going to factor. Should have done that. So x plus 7, x minus 7 over x minus 7. We can reduce the x minus 7s because x cannot be 7. So this is the same thing as having x plus 7 sitting here. Okay? Limit as x approaches 7 from the left of g of x. Limit as x approaches 7 from the right of g of x. And then g at 7. Okay, from the left and from the right, I'm going to be using this piece. From the left and from the right, I'm using this piece. And either way, when we put 7 in for x, we get 14. So both of these are 14. G of 7, now I'm using this piece. G of 7 will be 14 minus 1, which is 13. G has a discontinuity at x equals 7 since the limit as x approaches 7 from the right of g of x, while it is equal to the limit as x approaches 7 from the left of g of x, they are not equal to g of 7. Okay, that's it.